OCR Statistics, Discrete Random Variables 2, Binomial and Poisson Distributions. This is video 2.4 on calculating probabilities using the Poisson distribution. We showed you this formula in a previous video, and this is given to you in the formula booklet. Remember that lambda is our parameter, and x can only take positive integer values. This means that we're going to use the Poisson distribution as a model for the situation we're in. Let's look at an example. This case is about the number of cars passing a point on a road in a 5-minute period. We're modelling it with the Poisson distribution, and we're told that the parameter is 4. We can write this like this, because lambda is 4. But what does that actually mean in the context of the cars passing in the road? Well, essentially we're being told that the rate of cars passing is 4 in every 5-minute period. We're going to use the Poisson distribution to find the probability that in any 5-minute period, what's the chance of only 2 cars going past? And then in part B, we're going to work out the probability that fewer than 3 cars go past. So first of all, for part A, remember we know that lambda is equal to 4. In this case, because we want what's the probability of 2 cars going past, x would be equal to 2. So to find the probability that x is equal to 2, we would substitute lambda and x into the formula. E to the power of minus 4 multiplied by 4 to the power of 2 all over 2 factorial. This would give me 16 e to the power of minus 4 over 2 times 1, which is just 2, and cancels down to 8 e to the minus 4. And this is equal to 0.147. So this is the probability that in a 5-minute period, only 2 cars go past. Here it is written out neatly. Now, part B of the question asks us to find the probability that fewer than 3 cars go past. If fewer than 3 cars go past, that means that 0 cars, 1 car, or 2 cars could have gone past. So we can write it like this. The probability that x is less than 3 would be equal to the probability that it's 0, 1, or 2. Now we already know what the probability of getting 2 is because we did it in part A, and it was 8e to the minus 4. So we already know that. Let's look at 0 and 1. So we would have e to the power of minus 4 again, and then we have lambda to the power of x, that would be 4 to the power of 0 over 0 factorial. And the second one would be e to the power of minus 4 times by 4 to the 1 over 1 factorial. And we already know that this is 8e to the minus 4. 0 factorial is just defined as 1. This is 1, this is 1, so we get e to the minus 4. We can cancel this down as well. This would just be 4e to the minus 4 and 8e to the minus 4. So altogether we have 13e to the minus 4. And this gives us an answer of 0.238. Here it is written out neatly. Now, if you're a bit like me, you will feel like, oh, this is very long and laborious and I'm very likely to make a mistake. Well, thankfully, there is a function on your calculator that can do this for you. So on your calculator, you need to go to Poisson cumulative distribution function. And once you've gone into there, all you need to know is that lambda is equal to 4, and in this case we're going to enter that it's less than or equal to 2. And you can just directly do that with your calculator and it will come straight out with the answer of 0.238. So just pause the video and check that you're able to do that with your calculator, using the calculator guide if necessary. Now it is useful to look at GeoGebra to both check our answer and to kind of make sense of what's happening here. Okay, we're now in GeoGebra and we've selected to be in Poisson. Remember in GeoGebra they use mu rather than lambda, but this is our parameter. So I've entered in 4 because we were told that our parameter is 4, and we're interested in finding out what's the probability that fewer than 3 cars pass in these 5 minutes. So I've set x to be less than or equal to 2. So you can see in our diagram that this is showing it could be 0, 1 or 2, and the individual probabilities over here. So we've added them up to give a final answer of 0.238. This was 2.4 calculating probabilities using the Poisson distribution. The next video, 2.5, is on the properties of the Poisson distribution.